Hi everyone. Today I'm going to solve the Leetcode question, create binary tree from descriptions. This was a problem that was asked in the weekly contest just yesterday, and it's about binary trees where you're trying to construct a binary tree where you're given a list of descriptions where the descriptions is parent, child, and is left. So you're indicating um, whether it's the parent of the node, and then also you're getting the children and just one child, and then you have the is left to let you know if it's the left or the right child. So if you see is left equals 1, that means it's the left child, and if is left equals 0, then it's the right child. And this one, there's an example here as well of the problem so that you have a better understanding. And you can see here in the input there's 20, 15, 1, and 20 is the parent, and then to the child is 15, and it says 1, so it's to the left. And then there's 20, 17, 0, so 17 is 0, so it's going to the right. And then you also have 50, 21, and 20 is to the left because of the 1 here. Then there's 50, 80, 0, and 80 is to the right because of the 0, and then you have 80, 19, 1, which is to the left as well. And in this problem, what we're trying to do is we're trying to return back the root and generate this binary tree. So here as well, there's another example of there's 1, 2, 1, 2 is to the left, and then there's 2, 3, 0, 3 is to the right, and then 3, 4, 1, 4 is to the left. So this is how it is generated. And then again, what you have to do is you have to return the root of this tree. So this is the problem, and there's a couple approaches, and one thing that it helps you out with this problem is it's telling you that the binary tree has unique values. So whenever you see unique values, it's kind of an indication that you can use a hash map, because hash map, as you know, you can only have one key. You can't have duplicate keys in the hash map. So when you see that, that's a great indication that you can use a hash map. And what the approach that I think is best to solve this problem is to store all these values, the parent and then the left and right child, into the hash map. And then the way that you find out if um, if it's the children or if it's the root, um, to find the root. So if you wanted to find the 50 here, is that you would be also storing another set with all the children in the set. So for example, here when you have 50, 20, 80, 15, 17, 19, what you can do is you can have a set where the set stores the 20, the 80, the 15, 17, and 19. And then what you would do is you would just go iterate through all the values in descriptions. And then you would see that when you go through 50, that it's not part of the set, and that means that it's the root, because the root is not going to have any children. So this set, all it's going to store is all the children. So that's a reason of the set. And then the way that you would solve it is by having a map where you would have a key value pair. So it would be an integer key, and then in the value you would be storing um, a tree node. So this is what the map would look like, and then you would keep storing these values in there with the left and right children, and then in the end you would just be returning this root here. So that's the approach in which you can solve this problem. If you haven't already attempted this problem, I would recommend that you try solving it yourself and then come back to this video where I'm going to do the solution. But otherwise, just pause this video and try it yourself, and I'm going to solve it now. All right, so now I'm going to solve this problem. And as I had mentioned, we're going to create a map with an integer and tree node. So this is going to be which is going to store the whole binary tree. So we'll do equals new hash map. And then we'll also have a set of all these keys. So we'll have the integers, children. This is going to store all the childs equals new hash set. And then now to solve this problem, we're just going to iterate through this array. Int descriptions. Okay, and then we're going to get the values. So we're told that the first value is parent. So we'll do that. We'll get the parent equals R0. And then we have the child equals R1. And then we have is left equals R2. So that will be the three values that we're trying to get from this array. And then now what we'll do is we're going to store the children into the set dot add child. So we'll add that, and then we'll get the current. We'll create a new value here with the parent. So we'll get node current, and this should be tree node. The tree node current equals, and then we might already have stored this value in the hash map. So what we'll do is we'll use the get or default function, and we'll just put the parent value. If it's not there, then we create a new tree node of the parent. Okay, and then now that we have that value, now we're going to do the left. We're going to check the left to see if there's a value. If is left equals 1, then we then the current dot left equals, and then we might already have this value in the map, so that's why we'll use the get or default function. And then here would be the child or the new tree node. And then we also need to store this value into the hash map so that we can get it later on. So we'll be storing it in the hash map. So we'll put the child and then current dot left, which is the value. Then because we're only getting one value, which is either going to be the left or right child, we can just do an if else here. So we'll just do current dot right equals map dot get or default here again, the child for the new tree node child. Then we're going to put this value here into the hash map. So it's child and then current dot right this time. Okay, and then finally we need to also put this root node, the current, into the hash map. So we'll just put another map dot put the parent and the current, which is the value that we have here. So that's the hash map, and then from this for loop we'll have the whole tree generated. So all we have to do now is we just have to get the root node, and that's what we want to return in this function. So for that we have to again do another for loop with the values of descriptions. So once we get this values, we'll check if the children set contains this value. So the child is always the second value. So int child equals R1. Right, and then so we're just going to check the children to see if it's already in the set. Dot contains, and this is a if it includes, if it contains, if it does not contain, then this is the root. So we need to return this root, and to do that we just need to get this key. We have to store this key, and for now we'll just put it as -1. Then we just get key equals child, and here, oh, and sorry, so this is actually, if we want to iterate through the parent, not the child. So because we want to get what is the parent node, so it's R0 here, and then we have to check if this parent is inside the children. So that's what we have to do. So it's actually parent, and then key equals parent as well, and then we'll just break out of this loop because we got the value that we want. And then what we have to return is this this parent, which is going to be map.getParent. And yeah, so that should be everything that you need to do to solve this question. So what we did at the beginning was we did an O of n function where we put all the values and constructed the tree node, binary tree. And then finally we went through all the keys and found where the parent is. So we got the parent, so which is what we iterated, which is another O of n loop, and then we returned this parent. So let's just run this and see if it's correct. Line 57. Oh yeah, so this is key. All right. Yeah, and it looks like it's correct. So let me just submit it. And there we go. So memory usage 100% and 40% better submission. So this is how you can solve this problem. If you have any other questions regarding this problem, or if you have anything else that you would like me to solve, let me know in the comment section, and please subscribe for more videos in